Alrighty, everyone. I hope you're all doing well. And for this particular lecture, I'm going to be reviewing basically the most important concepts to remember from the Daniel Schachter article that you guys read for homework 3. Okay, so the Seven Sense of Memory paper is probably one of the most influential publications in cognitive psychology or in the field of human learning and memory. And one of the reasons why it was so important or so influential has to do with most people's conceptions about the memory system. So most people assume that the only time that you're going to have kind of global or pervasive forgetting or errors in your memory system is if you have some sort of underlying disease, right? So it might be something like Alzheimer's or dementia or maybe a traumatic brain injury, something like that, right? But in the absence of amnesia or dementia, most people assume that otherwise, if you're healthy, that you shouldn't experience that many memory lapses throughout your lifetime. Right, but that's a misconception about memory. So it's actually quite common for all people, even those who are considered healthy or neurotypical, to experience a lot of different lapses in memory. And so what Schachter argues is that many of those lapses in memory are actually quite adaptive or helpful to us in terms of the tasks or goals that our memory system helps us to accomplish. Okay, so what I'm going to do for this lecture is I'm going to review each of the different types of sins that Dan Schachter talks about. And then lastly, we're going to talk about how each of those sins, in quotations, are actually very adaptive in that it enhances what you are able to remember, right? So obviously, you forget things or might distort certain aspects of a particular event, but even those distortions or lapses in memory can be helpful in certain circumstances. Okay, so we'll go through each of the 7 sins together, and then at the end we'll talk about how they can actually be adaptive or helpful for your memory system. Okay, so the first 3 sins that Dan Schachter talks about are basically examples of different types of forgetting. Are there examples of cases where the information that you're trying to remember is no longer accessible or available to you? Right? So whatever that memory representation is that you're desiring to retrieve is no longer available, right? So he's trying to explain 3 different examples of when such forgetting might occur. Okay, so we'll go through transience, absent-mindedness, and blocking, which are all examples of cases where the desired information that you want to access is no longer available, or you can no longer get to that memory representation. Okay, so transience, we've actually talked about transience at length before, but we referred to it by a different name. So transience or decay simply refers to the loss of information over time, or the phenomenon whereby your memory for events, experiences, or even just general knowledge becomes less accessible over time. And this might go without saying or seem fairly obvious, but memories are more likely to decay with the passage of time when you don't use them, right? So one of the best ways to ensure that you protect against the gradual erosion of memories is to make sure that you're continuously interacting with the information or using the information for a goal-directed purpose. Okay, so this is actually a phenomenon that was first illustrated by Ebbinghaus in his sort of classic studies of the forgetting curve, right? So you guys might recall that Ebbinghaus was the one who drafted those different lists of 13 nonsense syllables, and then he learned them to criterion using his memory drum, right? And he looked at how long it would take him to relearn the list at various delays. And then he would subtract the time that it first took him to learn the list. Okay, so he would take the time that it first took him to learn the list and subtract however long it took him to relearn it, right? And whatever the answer to that basic subtraction equation was his savings, right? And what he found is that the time that he saved with initial learning declined over time, right? So this was his quantitative measure of forgetting. And what he found when he repeated this procedure for several trials is that he had a rapid drop in savings early on, but then it became more gradual, right? So that's just an example of how we might quantifiably represent transience. Okay, so another example of transience or illustration of transience are individuals who have developed what's called retrograde amnesia. So people with retrograde amnesia usually have sustained some sort of damage to their hippocampus, and because of that, they're no longer able to form new long-term memories. Or another way to say that is they're not able to move information from short-term memory to long-term memory. Okay? So you guys all remember the case of Henry Molaison, or HM as he's referred to in the literature, who had his hippocampus removed to treat his very, very serious or severe medication-resistant epilepsy. And as a result of having his hippocampus removed, he was no longer able to form any memories for the events or experiences that he had after the surgery, unless they were implicit memories. So for example, he could learn classically conditioned associations, he could learn various tasks that relied on motor memory. So for example, tracing a star using a mirror, and so forth. But as far as remembering any of the events and experiences that occurred after the surgery, he was not able to. So this provides a very illustrative example of transience, because anytime you asked Henry Molaison anything, for example, if you asked him to keep 5 different numbers in mind, right? And then you left and came back 5 minutes later, as soon as you provided his attention was focused on those numbers, he would be able to remember them, right? But as soon as his attention was diverted to something else, right? So as soon as he was no longer focusing on those numbers, the information would be rapidly forgotten, right? So we see there that his short-term memory is functioning because he can engage in rehearsal and attention, which are both control features of, short-term memory. But again, as soon as you divert his attention so that he's no longer able to engage in rehearsal or to focus on those items, they're rapidly forgotten with the passage of time, right? Because he's not able to move them from short-term to long-term, right? So that's another example of transience. Okay, our next example of errors of omission, which occur when information is omitted or forgotten from memory, is absent-mindedness. So absent-mindedness is basically forgetting that happens because you aren't paying attention, right? So again, if we look back at the modal model, the way that we move information from sensory memory, or a brief snapshot of whatever sensory information is coming in, to short-term memory is we have to pay attention to it, right? So attention is going to be really, really important. It's again a really, really important control feature of our memory system that allows us to retain information. So what are some examples of forgetting that happens simply because we're not paying attention? Well, one example you guys are already familiar with, so I don't know if you can see this image very well, but you might remember when I asked you to draw a penny from memory for your memory lab assignment, right? So most of you found that task fairly difficult, I would assume, and very few of you were able to draw a picture perfectly from memory of what a penny looks like, right? And in fact, this was something that cognitive psychologists did in an experiment. And this picture shows on the left-hand side an actual penny, and then there are 8 different examples of the drawings that people came up with, right? And you might see that all of those are fairly detailed, right? But they're also fairly inaccurate, right? So very few of them look identical to the actual penny, right? And that makes sense because in our daily lives, right, it's not really necessary for us to know or to be able to generate from memory exactly what a penny looks like, right? That's not really something that we're typically asked to do, but there are other features that it's much more important that we pay attention to. So for example, it's important for us to know that a penny is worth 1 cent. It's important for us to know that a penny is made of copper and not silver, so that we can identify it on the basis of color. It's important for us to know maybe the relative size of a penny compared to other coins, so that if we're reaching into our pocket to fish one out, right, we can sort of tell based on the tactile sort of sensations that we get which of the coins might be a penny, right? So all of that information is going to be relevant for us to pay attention to, but to be able to generate what a penny looks like with this degree of specificity probably doesn't matter very much. But even in cases where the information is fairly important, oftentimes we still don't pay attention. So this example comes from an experiment that one of my advisors in graduate school did. So I went to graduate school at UCLA, and it just so happens that our psychology building had several different floors. So it was actually, I think it had 9 stories. So at some point, the president of the university was walking around on campus, and he noticed for the first time how many of the buildings on campus had several different stories. And so it occurred to him, it might potentially be a safety risk if there were a fire, right? And we were tasked with getting all of the people in the building outside, given the number of floors and the fact that, the elevator probably wouldn't be working and so forth. And so he decided to start an initiative on campus that was focused on fire safety. And one of the things that he did as part of that initiative is he mandated that certain faculty members would basically be safety captains that would be charged with making sure that everyone was familiar with all the safety related protocol, and they did like fire drills and things like that. So it just so happens that one of these safety officers was a cognitive psychologist working in the psychology building named Alan Castell. And so as he was going through the process of getting all the faculty and students trained in various safety protocols, he was, one of the questions that he was tasked with asking everyone is if they knew where the nearest fire extinguisher was, right? So he thought surely everyone should know kind of where this is, but he found that most people didn't know. And one of the people that he interviewed was a man who had been working at UCLA for 25 years and who had the office pictured for 25 years. But when Dr. Castell asked this man where the nearest fire extinguisher was, he said he didn't know, right? And he was very confident. Oh, I have no idea where the nearest fire extinguisher is. Well, very comically, it turns out that the nearest fire extinguisher was literally right next to his office, and he had been in that office for 25 years, right? So even when we see something every single day, and even when it's fairly relevant for our survival, sometimes we forget simply because we aren't paying attention. So one final example is the example that was illustrated in the article of the experiment by Simmons and Levine, and it's referred to now as the door study. So for this particular experiment, they were illustrating something called change blindness, where people fail to notice even very dramatic changes in their environment, or they fail to detect changes in their environment due to inattention. So in this particular study, the psychologist basically went out into a busy city street and asked people for directions, right? So he held out a map of that particular city and asked them where to get to this location. And while the passerby was attempting to provide directions, right, someone came through with, in this case, a door or sometimes a painting, just a large object. And while the door was covering the face of the psychologist holding the map, they switched places with someone else, right? And even when it was someone of a different gender or someone of a different race, people often failed to detect the change or detect that it was a different person. And so this is a very dramatic illustration of absent-mindedness. And the theory is that what's happening is people are just processing their environment very shallowly, right? So we know that shallow processing leads to a decrease in memory as compared to something like deep processing, right? So when you're not really focusing on the particular environment in which you find yourself, right, you can miss a lot of critical information. Okay? So that's absent-mindedness, or forgetting that happens simply because you're not paying attention. Okay? So another example of an error of omission is blocking. And so another word for blocking is retrieval failure, right? So in this case, you've managed to encode the information. So it's not like the previous example of absent-mindedness, where you're not even really getting the information into your memory, right? So you don't even really have a memory representation stored in your long-term memory at all, right? With both transience and absent-mindedness, that information is no longer available or no longer stored in your memory. But with blocking, the information is available, you're just no longer able to retrieve it, right? Or it's rendered temporarily inaccessible. So sort of the classic example of blocking is what's called the tip of the tongue state. Right? So a tip of the tongue state basically occurs when you try to think of something, okay, and you might even have some ideas as to what the information might be, right? So for example, suppose I'm trying to remember the capital of Florida, right? And the capital of Florida is Tallahassee. But for some reason, I can't come up with Tallahassee. But I do know that it starts with a T, right? So I know that it starts with a T, and I know it sort of sounds like Tennessee, but I know that's not it, right? So that's kind of the classic manifestation of tip of the tongue. So you have partial recall, which means you're able to come up with maybe a first letter or words that sound the same. And you also have the experience that successful retrieval is imminent, right? So you have partial recall. You're able to think of some of the elements of the word you're trying to retrieve. And you also have the sense that if you just keep thinking about it, or if you just keep trying to retrieve the word, you'll be able to remember it, right? So this is a tip of the tongue state. And essentially what happens with a tip of the tongue state is the wrong answer that you've come up with. So in this case, Tennessee is the wrong answer, or the ugly stepsister, as it's sometimes referred to in this literature, right? That looks kind of similar to what I'm trying to retrieve, but is the wrong answer. So the incorrect answer, or the ugly stepsister, is going to become very, very prominent in my mind, or very, very accessible in my mind. And it's basically going to block out or displace the correct answer. So remember when we talked about retroactive and proactive interference, and I said that most forgetting that happens is actually due to the displacement of some information by other information? This is another example of that sort of displacement. So the wrong answer that I'm thinking of blocks out or displaces the correct answer. Okay? So if that's the case, right, then the best thing you can do to eliminate or prevent a tip of the tongue state is, rather than continuing to try to come up with the right answer, right? Because if you keep trying to come up with the correct answer, that incorrect answer is just going to become more and more accessible. So the best thing you can do for yourself is to think about something else. right? So thinking about something else is going to make it easier because you're no longer going to be sort of reinforcing or emphasizing that incorrect answer anymore, right? So as that incorrect answer becomes less and less accessible over time, it's going to be easier for you to come up with the right answer. So just do something else. Think about something else for a while. And eventually what you'll find is that when you're no longer focusing on the question or trying to retrieve the word, the information, the correct information, will become recallable or retrievable again. So that's one example of blocking. Another example is something called part list queuing. So basically with part list queuing, what researchers have found is that if you give people a list of items to recall, right? But instead of just having them try to recall the entire list from memory, you give them part of the list as a retrieval cue, right? So for example, you might ask people ask people to come up with state capitals, right? So there are 50 state capitals. So instead of asking people to remember all 50 state capitals or generate all 50 state capitals, you might give them 25, okay, or give them half of the list and then have them come up with the remaining 25 by themselves, right? So what researchers found when they did this is people's ability to generate the remaining state capitals was actually worse compared to people who weren't given that first part of the list, right? So people who weren't given part of the state capitals as a cue came up with more state capitals by themselves than people who were given 25 state capitals as a cue, right? So the reason for this is that that part of the list that people are given as cues blocks out or prevents them from being able to recall the remainder of the list, right? So that information that they were given becomes very, very accessible and prevents them from recalling the remaining information. So again, this is just an image that kind of illustrates the partless queuing experiment. So let's imagine that we give people a list of the words steam, sugar, violin, carpet, right? And in the control condition in gray, we have them come up with the whole list without a cue. And in the case in blue, we give them two of the words, violin and sugar, and have them come up with the remaining words. If we look at their performance, we actually find that people in gray are able to remember more of the list than the people who were given part of the list as a cue, right? So again, why this happens is that the information that people are given is going to displace the remaining information or hinder them from being able to generate the remainder of the list. Okay, so we've talked about sins of omission or cases of forgetting where the information is no longer available in memory, either due to transience or decay, absent-mindedness or inattention, or blocking or retrieval failure, as it's sometimes known. So our next set of sins of memory are sins of commission. So with sins of commission, unlike with sins of omission, there is actually some form of a memory that's present and available for recall, But the problem is that that memory has become distorted, okay? Or that memory has become inaccurate in some way. Okay? So we'll go through each of the types of sins of commission. There's misattribution, suggestibility, and bias. So let's go through each of those kind of one by one. Okay, so with misattribution, essentially what's happening is we're able to recall something, but we attribute it to the wrong source. Okay. So one example of that might be if you think about a particular fact that you've learned, you might remember it as something that you heard in lecture, when in actuality you read about it in the textbook, right? That's an example of source misattribution. More sort of relevant examples of source misattribution, or more sort of real world examples with more serious consequences, are cases of misattribution that result in false convictions, right? So one of the classic examples of this was the case of Donald Thompson. So Donald Thompson was a very famous psychologist in the 1980s who did a lot of different media appearances. So he was often, he did a lot of press tours, he wrote a lot of books for the popular press and did a lot of sort of book tours. He was featured on a lot of different talk shows, etc. And in one particular case, a woman was raped, and while she was being sexually assaulted, the TV was on, and it showed Donald Thompson on one of his talk show appearances. And so she later identified Donald Thompson as the perpetrator, because she saw his face and it was familiar to her, and she attributed that familiarity to the fact that he was the perpetrator, and not to the fact that she saw him on TV, right? So that's a very compelling and very serious case of source misattribution, right? So in this case, she had a memory for a particular experience, in this case of a sexual assault, but she misattributed to Donald Thompson the role of perpetrator, when in fact she had just seen him on TV, right? So it's another example of being able to generate a memory, but attributing it to the incorrect source. Sort of the classic way that source misattribution has been studied in the laboratory is through something called the false fame effect. So in the sort of classic paradigm that cognitive psychologists use, we have people come into the laboratory and they read a list of non-famous names, right? So for example, they might see Sebastian Weisdorf, or Leslie Norman, or Hope McCulley, right? So all of these names are names of non-famous people, okay? And then in the immediate test group, okay, they're given a list comprised of some of the non-famous names that they just read, as well as new non-famous names that they haven't read, and some actual famous names, right? And so what they have to do in this test is they have to indicate whether the names are famous or not, right? So is Leslie Norman famous? Yes or no? Is Donald Trump famous? Yes or no, right? And so the result is that most of the non-famous names And definitely the non-famous names that they saw previously were correctly identified as non-famous, right? So when people were tested immediately, they didn't have a lot of difficulty remembering that a particular name was not famous, particularly if they had seen that non-famous name previously. However, there was a delayed test group where they were given the same task of indicating whether a particular name was famous, and they were shown old non-famous names, new non-famous names, and famous names, right? But in the delayed test group, the test took place 24 hours later, right? So in the delayed test group, some of the non-famous names were misidentified as famous, right? So what people were doing is they would see a particular name like Leslie Norman, right? And that name would feel familiar to them because they saw that name 24 hours earlier in the acquisition phase, right? But they would attribute that sense of familiarity to fame, right? And so the idea is that the name felt familiar to them, right? But they failed to remember having seen that name in the earlier acquisition group, right? Because it's been 24 hours, and as we know, information becomes less accessible with time due to transience, particularly if we're not actively engaging with that information, right? So their memory for that acquisition phase was reduced or decreased due to that 24-hour retention interval, right? But the name continues to elicit some sense of familiarity, right? So they assume I must be familiar with that name because it's the name of a famous person rather than the name of a non-famous person that I read about earlier in the experiment, right? So that's kind of the classic laboratory demonstration of misattribution. Another example of a memory distortion or of an error of commission is suggestibility, right? So suggestibility is simply memory errors that occur because we incorporate information provided by others, particularly misleading or false information, into our own recollections, right? So again, it's an error of commission, so it's a distortion or inaccuracy of memory. And particularly, it's one that results from us incorporating false or misleading information into our own recollection. Right? So kind of the classic demonstration of suggestibility is the misinformation effect, right? So in one of the earliest demonstrations of this, Loftus and Palmer had people come into the laboratory and watch a video of a car accident, right? So they watched a video of a blue car running into a red car on a busy street. And participants were asked various questions about what they had seen. And what Loftus and Palmer asked participants to do is she asked them to estimate the blue car's speed. So she said, how fast was the blue car going when it either hit the red car? How fast was the blue car going when it contacted the red car? And how fast was the blue car going when it smashed into the red car, right? And what she found is, depending upon the particular verb that she used, right, that had a direct impact on the estimates of speed that the participants provided, right? So when people were asked to estimate how fast the blue car was going when it contacted the red car, their estimate of speed was around 31 miles per hour. But this jumped to 34 miles per hour when contacted was replaced with hit, right? And perhaps in the most striking case, 34 increased to 41%, almost 41%, when participants were asked to estimate how fast the blue car was going when it smashed into the other car, right? So what people are very clearly doing in this case is they're making an inference based on the verbiage used, right? And that's changing their recollection for the event, right? So even more strikingly, Loftus and Palmer had participants come into the laboratory a week later, and she asked people in all three groups if they had seen broken glass in the video. And something like 42% of people in the smashed condition said that they did remember seeing broken glass, as compared to like 12% or 20% in the contacted and hit group respectively, right? So what that means is, again, people are incorporating this misleading information that was given to them by the particular verbiage that was used, right? And that's impacting their recollections later, making them more likely to assume, right? If they're assuming that one of the cars smashed into the other car, right, then that supposition is going to lead them to assume that there must have been broken glass, right? But all of that information is false, right? So that's an example of a kind of a classic example of suggestibility, right? Another example is in the domain of false memories, right? So it is possible to implant an entirely false memory in a variety of different situations. So in the classic false memory paradigm, essentially what happens is if you're a participant in a false memory experiment, the experimenter is going to send home a questionnaire, probably to your family members, right? And ask your family members to come up with 5 examples of stories from your childhood, right? So your mom and dad might fill out a survey and talk about, when you broke your arm at preschool at 3 or 4 years old, when you went on your first trip to Disneyland, etc. Right? So your parents will come up with 5 actual events of things that have happened to you. And then what Loftus and colleagues, or really anybody wanting to study false memory, would do is they would pick one entirely false event. And what your task as a participant in this experiment would be is Loftus would interview you about those childhood experiences, right? So first she would interview you about your trip to Disneyland and what it was like in the hospital when you broke your arm. And then she would start to ask you about this entirely false event. And what Loftus found is that first people are sort of reticent and they can't really remember excuse me, the false event. But over time, in successive interviews, they start to generate very highly detailed reports of this entirely false event. So I'll show you guys some examples. So in this example, the researchers took an actual childhood photo and photoshopped it, or created a photoshopped image of the child flying in a hot air balloon. And so what they did is they told people, they asked them about actual experiences, and then they asked them about their trip in a hot air balloon in 3rd grade and showed them this particular image. And 50% of participants in this experiment accepted this entirely false event as true and gave very detailed reports of their experiences. In another classic example, they didn't use a doctored photo at all or a photoshopped image. They took an actual image, but manufactured an entirely false account of how that particular participant had misbehaved in class and gotten punished. And again, over half of their participants later gave very detailed reports of this entirely false event of misbehaving in class, right? So what these two examples very clearly illustrate is that just like we see with regular memories, right? So even with actual events or actual knowledge that you're trying to remember, right? One of the best things you can do is either generate an image or try to remember an image, right? An image is a very powerful retrieval cue. And as it turns out, that's the case for false memories as well. Anytime you introduce an image to participants, they're going to generate more false memories than they would otherwise. Okay, and a final example, one of the things that Elizabeth Loftus was criticized for in her false memory research is people were concerned about the possibility of implanted false memories impacting people's future behavior. And so in this particular study, she wanted to see if implanting an entirely false childhood event would impact future behavior, and particularly if that event was somewhat traumatic. Okay? So in this particular study, they implanted an entirely false event of participants having gotten sick from a fairly low frequency food, or a food that they wouldn't have eaten a lot of, presumably. So the two kind of examples from this study were strawberry ice cream and egg salad, right? So the way that they conducted this experiment is they implanted this false memory, and then they invited people back 1 week later to participate in a picnic, right? And as you might expect, lo and behold, that low frequency food that they were led to believe they had gotten sick to was being served at the picnic, right? And what they found is that a statistically significant number of individuals who had been led to believe that they had gotten sick from this food declined to eat that food at the picnic, right? So what this suggests is that implanting false memories can have fairly significant consequences on people's future behavior, right? People are now less likely to eat this food because they've been led to believe that the food makes them sick, right? So all of these examples, again, the misinformation effect and false memories, are examples of suggestibility because people are incorporating entirely false or misleading information into their memory, right? And their future recollections of the event are reflective of that. Okay, so our second to last example of the 7 sense of memory, and an example of an error of commission because it involves some degree of distortion, is bias. Okay, so essentially what bias is referring to is the fact that what we recall, right? So anytime we retrieve something from memory, that recollection is going to be heavily influenced or dependent on our pre-existing knowledge and beliefs about the world, right? So remember when we talked about schemas in this class? So a schema is basically just something that helps us to either organize our experiences, or sometimes schemas give us a particular script that we might follow in a particular experience, right? So for example, our schemas might tell us what typically happens at a birthday party, right? So we know that at a birthday party, it's customary to exchange gifts and it's customary to eat cake, right? So obviously, if you know that you've been invited to a birthday party, then you would modify your behavior accordingly and make sure that you have a gift for the person whose birthday it is, and maybe you have made room in your meal plan or whatever to eat some cake, right? Similarly, your schema for what happens at a restaurant would tell you that, first the hostess seats you and then you look at a menu and so forth, right? So all of those are examples of schemas in that our prior experience kind of tells us what to expect in a familiar situation, right? So our schemas, again, help us to organize our experiences and also give us a sense of what to expect should we ever find ourselves in a similar situation, right? But our schemas sometimes lead to distortions of memory. So in the classic example of bias or distortions in our memory that result from schemas, this was a study that was conducted by Brewer and Transience in 1981. So essentially what they did is they had participants come into a graduate student's office and they stood alone in the office for 35 seconds. So the experimenter told them, okay, I have to go grab something really quick from my office. Stay here and wait for me, right? And after that 35 seconds was over, the experimenter came back and said, okay, I want you to tell me, I want you to either write down all of the objects that you can remember that you saw in the room, or I want you to draw me a picture of all of the items that were in the room, right? So what was particularly striking about the results of this experiment were the things that people remembered, right? So almost everyone in this experiment remembered that there was a table and a chair in the room, right? So they remember that there were tables and chairs, and this makes sense from the perspective of schemas, right? Because in almost every office that we've been to, right, if it's an office, it's going to have a table and chairs, right? So that was an example of an accurate memory, but many different people, 20%, more than 20% of people, incorrectly recalled seeing books on the shelves, right? But there were no books on the shelves in this particular office, right? So I believe 20 out of 30 participants remembered seeing books on the shelves, even though there weren't any books on the shelves. Only 9 out of 30 participants recalled seeing the skull that's on the shelf, right? So if you look very closely at this image, there's a skull on the shelf, right? But most people aren't expecting to see, hopefully, body parts when they walk into an office, right? So this is a fairly low frequency item, right? So people's schemas are telling them incorrectly in this case that there were books on the shelves, but are typical schema of an office doesn't usually include skulls, right? And so only 9 out of 30 participants recalled seeing a skull, right? So again, what this illustrates is how our schemas can guide memory retrieval, right? So our schemas tell us that a typical office is going to contain a table and chairs, a typical office is going to contain books, maybe a computer, right? But we wouldn't really expect to see something abnormal like a skull, right? So again, almost everyone correctly remembered seeing a table and chairs. Many people, 20 out of 30 participants, incorrectly recalled seeing books, and only 9 out of 30 participants correctly remembered seeing the skull. Again, because their schemas were guiding what they remembered. Okay, so our final sin of memory is not a sin of omission or forgetting something. It's not a sin of commission or distorting something, but rather it's remembering something that you would rather forget, right? So this is particularly prevalent in instances of trauma. So, and particularly in the diagnosis of post-traumatic stress disorder, right? So post-traumatic stress disorder, or PTSD, one of the hallmark symptoms is called re-experiencing. So that's where you continue to experience the trauma even months or years and years after it occurred. So that re-experiencing might occur in the form of a flashback, or it might occur in the form of a nightmare, right? Those are both examples of kind of reliving the trauma over and over. And so one of the classic studies illustrating how persistence works in the laboratory was what's called a directed forgetting study, right? So in healthy controls, right, or people without trauma, or neurotypical people, it is actually possible to train people to forget information, right? So in the classic example, you show people a list of words, right? And some of the words you tell them to remember, and other words you tell them to forget. And on a future recall test, even when you offer people money to generate some of those forget words, they're still not able to, right? So it's very easy to sort of train people to selectively forget information in the laboratory, right? And the idea is, again, people simply don't pay attention to the forgotten items. If they're told to forget them, they kind of ignore them, and that ignoring eventually leads to a lack of a robust memory trace for that item, right? So using the same directed forgetting paradigm, they brought in people without PTSD to serve in the control group, and combat veterans with PTSD to serve in the experimental group, right? And so what they looked at is how they looked at the words that people were able to remember compared to the words they were told to forget, right? Or rather, they looked at, so some of the words people were told to remember, and other words they were told to forget. And they looked specifically at trauma-based words, or words that had to do with combat. So in people without PTSD, they showed kind of a standard directed forgetting effect, right? So as you can see with the gray bar compared to the white bar, they were able to successfully recall more of the trauma words they were told to remember than the trauma words they were told to forget, right? So that's a standard directed forgetting effect, right? Compare that now to people with PTSD. So remember that we're talking about combat relevant words. Well, it turns out people with PTSD were not able to forget the trauma-related words, right? So even though in most people it's very, very easy to elicit this kind of selective forgetting, people with trauma were not able to forget or ignore the trauma-related words even when they were told to do so. So their memory performance for words they were told to remember was identical to their memory performance for words they were told to forget, right? So this is a very compelling laboratory demonstration of persistence, or of the fact that particularly in the instances of trauma, right, it's very, very difficult to disrupt memory for that trauma or prevent memory for that trauma from intruding or perseverating in the person's sort of consciousness or attention. Okay, so that's persistence, or the inability to forget information, particularly in instances of trauma. Okay, so the final thing that I wanted to talk about is really one of Schachter's main points, is that even though all of these examples of forgetting a memory or distorting a memory or not being able to forget something, even though those are really painted as failures of the memory system, right, they're actually quite adaptive. Right? So let's go through how all of these 7 examples are actually helpful or adaptive for us. Okay, so in the case of sins of omission, where we're no longer able to access a particular memory trace, or it's no longer available to us, so we forget that information, the main adaptive quality that underlies sins of omission is try to imagine what it might be like if they weren't there, right? So for example, try to imagine what it might be like if our memories functioned as a tape recorder or some kind of recording device where all of our events and experiences were remembered perfectly, or we were able to keep a perfect record of all of our events and experiences, right? You might think that that would be really helpful and that would be a good thing. But inevitably, what would happen in that case is if we're never able to forget something, either with the passage of time or with our attentional system in place, right? Or with other information replacing previous information, right? What that would mean is that we would become constantly inundated with information, right? We would have to pay attention to every single solitary thing that happened to us, right? And we would again have a perfect record of things that happened many, many years ago, right? And so what would happen is we would become inundated with information, right? So our cognitive system would constantly be operating at capacity, right? And it would be up to us to figure out what is most relevant. And once we figured out what is most relevant, we would have to search through this massive catalog of information to get to it, right? So imagine if you were a professor that had been coming to Mercer for 50 years, right? So on any particular day, you park your car, right? And then after working for 6 hours or 8 hours, you go back to the parking lot and you now have to remember where you parked your car, right? If you had a perfect memory system, you would then have to go through this kind of massive Rolodex of every place that you parked your car for the past 30 years, right? So that would be a very lengthy, effortful, sort of painstaking process that is not in any way efficient, right? So really the reason why sins of omission are helpful is they function as cognitive editors, right? So either forgetting stuff that's no longer relevant because time has passed, forgetting stuff because it wasn't important enough for you to pay attention to it in the first place, or forgetting stuff because it's been replaced by more relevant information, right? All of those cases are examples of keeping your memory current, so to speak, or keeping a memory system that best reflects what is most relevant to you in any given moment. Right? So sins of omission are basically cognitive editors that make sure that you have the most up-to-date relevant information and only the most up-to-date or relevant information. Sins of commission. So cases where you do have an intact memory, but that information has been corrupted or distorted in some sort of way. Why might these things be adaptive? Well, kind of similar to the previous example of sins of omission, right? All of the issues with source memory that we see in misattribution or suggestibility at some level have to do with the fact that what we remember from our experience is often what's called a gist. So a gist is just a general summary, so to speak. So the most important features of an event or experience or general knowledge that we've acquired without a lot of the less important details, right? That's gist-based processing. And again, that's much more efficient than remembering exactly where you got the information. Was the information in my textbook or my lecture? Well, it doesn't really matter as long as I know what the information is, right? And incorporating information that we infer from context, right? So even, obviously this is a bad thing when we're being given misinformation, right? But having the ability to incorporate more recent information into our recollections is often going to be beneficial, right? Because it's, again, it allows us to have the most recent, most up-to-date, most relevant information without getting bogged down in the details, right? So thinking about things in generalities and picking out the most important elements of our experience rather than getting bogged down in the details, right, is going to be helpful, as is making sure that our information is continuously updated in the face of new information, right? So all of those things are generally very adaptive. And even in the case of bias or memory errors that result from relying on schemas, right? Most of the time, schemas are very helpful. Like I said, schemas are going to help us to organize our experiences. They're going to guide our memory retrieval and to help us generate what is most important or what is most consistent, right? And they're also going to help us form expectations about what is most likely to happen or how exactly we should conduct ourselves or behave in familiar settings, right? So all of those things are very, very adaptive in that they allow us to predict the future, so to speak, and behave accordingly, and also to organize information and retrieve information in the most efficient way possible, right? So even though there are instances where relying on schemas leads to memory distortions, such as falsely remembering that there were books in an office when in fact there weren't, the fact is, in most cases, when we go into an office, there is going to be books, right? So having a schema that tells us what to expect in most cases is still going to be adaptive or helpful. Okay, the last one, persistence. This is arguably the most difficult case to see the adaptive value in, right? But if we again think about our cognitive system as being pre-wired or innately set up, so to speak, to allow us to preferentially encode information relevant to survival, right? Our minds are created in such a way or organized in such a way that we can best absorb the information that is relevant to our survival, right? So being able to remember, for example, a traumatic experience, even years and years after the event, might allow us to detect a future threat or to modify our behavior in such a way that that trauma is less likely to be experienced again, right? So for example, I think one of you gave the example of being bit by a spider, right? And being highly, highly allergic to spiders, right? If you have continual intrusive memories of that experience, it might be upsetting, but it also means that the next time you're camping or outside for a long period of time and you see a spider close by, right? Obviously, you're going to move or put yourself in a situation where that spider can't bite you, right? So it's going to allow you to, again, detect threats in your environment that have proven to be threats to your survival in the past and modify your behavior accordingly to prevent future threats. So again, the 7 sins of memory are, yes, they are memory distortions, or yes, they are instances where our memory system is such that we either forget something or distort something, or that we can't overcome traumatic information, right? But all of these cases have very clear adaptive qualities that help us to maintain an efficient and up-to-date cognitive system, and also help us to arm ourselves against potential threats. Okay, so this concludes my sort of summary or synopsis of the 7 sins of memory. Certainly, if you guys have any questions, I would encourage you to email me, particularly as you're working through your study guide. And remember, for exam 2, I'm going to choose 5 to 7 questions from the study guide, but I'm also going to have 1 or 2 surprise questions from the 7 sins of memory. So make sure you review this lecture and your article and your homework so that you're ready for that. All right, take care, everyone.